With the Earth's crust, the rocky part of the Earth is composed of several large raised plates. These plates are being created at some edges and being destroyed at others. They are also moving across the Earth. This theory is called plate tectonics. It was first put forth in 1963 by Canadian geophysicist by the name of Trude Wilson. Trude Wilson was instrumental in advancing the theory of plate tectonics. He suggested that the Hawaiian and other volcanic island chains might have fallen as a result of the movement of the plate over a motionless hotspot in the Earth's mantle. Hundreds of studies have proved that Wilson was right. However, in the early 1960s, his ideas were considered so radical that his hotspot manuscript was initially rejected by all the major international scientific journals. Basically, plates are areas of the Earth's crust that move as a unit. At the present time, there are 8 large plates, as well as a several number of smaller plates. According to the theory of plate tectonics, a plate has 3 kinds of boundaries with other plates: oceanic ridges, oceanic trenches, and transform faults. Most of the world's earthquakes and volcanoes occur at the plate boundaries. This is what you expect because plate boundaries are where a great deal of reflection and stress occur. A couple of things happen. One is that rock is forced out from the mantle in mountain hole as rubber at the ridges. Another is that rock is melted and forced back into the mantle at the trenches. This process of rock being swallowed or forced back into the mantle is called subduction. During subduction, as the plate dives into depths, we think part of it finds the surface in the form of volcanoes. The theory of plate tectonics and this theory of shift spreading have confronted the theory of continental drift. The movement of conference and the shift spreading was discovered in the North Atlantic and swept over in all the oceans. What we found is that in the areas around the oceanic ridges, the deep shifer is held by rising lava. It then spreads out sideways in both directions. So does the spreading of the ocean floor mean that the surface was increasing? No, not in the least. The shifer spreading doesn't cause an increase in the Earth's surface. And why not? Because the lava that rises and spreads from the oceanic ridges sinks again elsewhere in subduction zones, which are nearly identical with the ocean trenches. Subduction zones are areas of frequent earthquakes and usually associated with the rows of volcanic islands that accompany the ocean trenches. Subduction is currently happening beneath islands like Japan. Subduction is also taking place in North America beyond the end of the San Andreas Fault. This is where subduction plate is thought to have disappeared beneath the North American plate in recent geological time, leaving the volcano of the Cascade Range as evidence of its past existence. 唉。